are watching this, then Mr. Cho is out on jury duty again, right? That means we can all party. Not. I am here to make sure you do your work. Today, we are going to talk about percents. A percent is a part to total ratio. It is a number compared to 100.
Hi. I can help you with percents.
Hello, pretty lady. Of course, you can.
Let's play the video and review ratios before we get started.
Sure. Anything you want.
Good morning, everyone. Happy New Year for those of you I haven't seen yet. So let's get to our new topic. It's on the screen. It says introducing percent as ratios. Copy that on your table of contents. And you need a left side today. So if you don't remember, go back to your notes. You need to write a learning goal. And then it's what do I know, what I learned. Leave a little bit of room for the proof and a reflection. Okay, so get started, and you can press pause if you want. Okay, and then play back again. All right, so what I'd like you to do is the do now. Okay, it's copy this. You need to have this in your notebooks. I want you to change the following to a fraction or to a decimal. In the case of a fraction, if you can simplify it, then by all means, please do. You should simplify it always. Okay, and then the other one, change the fraction to a decimal. So take a couple of minutes. Again, press pause and come back, and we'll see what you did. Okay. So the first one was changing 0.12 to a fraction, and let me get my pen. Let's just choose black. Alright, so you have 0.12 and you want to change it to a fraction. Well, you know that this first decimal place value here is a tenth, and this is the hundredths. As you read this, or the same way you read it, you read 12 hundredths. Well, 12 hundredths is simply 12 over 100. Hopefully you simplified. You can divide top and bottom by 2 if you can't think of of the largest number that goes into both. In this case, it was 4, so you can divide top by 4 and bottom by 4. And 12 divided by 4 is 3, and 100 divided by 4 is 25. Final answer, 3 over 25. So 0.12 as a fraction is 12 over 100, but that can be simplified to 3 over 25. 3 over 8. How do we change that to a decimal? Well, hopefully you remember that we have to divide. The procedure here is to divide numerator by denominator. So here is the numerator, and that always goes inside. 3, 8, the denominator goes outside. So 8 cannot go into 3. So you add a little 0 on top of 3. You can add a decimal. By adding that decimal, you are allowed to bring a 0, or add a 0, I should say. 8 now can go into 30, 3 times. That's 24. Subtract, you get 6. You want to bring another 0 down to continue this a little bit. And 8 goes into 67 times. And then you get 56. And subtract that, you get a 4. You bring another 0 down. In this case, it's going to work out nicely for us. 8 goes into 40, 40 times. So 3 over 8 as a decimal is 0.375. Okay, that's that for that. Let's change it to the next page. Oh, actually, I wanted to do something. Here on this same page, let me just bring the screen down. But some of you might ask, well, 0.375, let's take that for a second. And you know that these two are equivalent to each other, but just in different formats. But you might ask, well, 0.35 as a decimal, as a fraction, when you initially change that, it becomes 375 over the last decimal place value here is the thousandths, the tenths, hundredths, thousand, and it's over 1,000, which can then be simplified. You divide top and bottom by, and I guess the biggest number here is 125, and divide the bottom by 125, and that's how you get 3 over 8. Okay, so 3 over 8 is 0.375, but if you have 0.375 to begin with, you would first change it to 375 over 1,000, which then simplifies to 3 over 8. That's how 3 over 8 and 0.375 are equivalent to each other, okay? So that's that for that. And next page. No, just did that. Okay, review. I want you to copy this, okay? We're going to talk about ratios, which is what a percent is, okay? And I just want to review because it's been a while. So a ratio is a comparison of two quantities. A ratio is something that happens over and over and over. It's a pattern, okay? So in this case, by the way, copy the whole thing, even the little heart and the stars. An example here that I want to use, that we're going to use, it's the heart and the stars, and I want you to come up with a part-to-part ratio, part-to-total, I'm sorry, ratio, a part-to-total comparison. So let's compare the number of hearts to the total, okay? So one way of writing this is that there is one heart to a total of 5 items. Okay, so for every 5 items, there is one heart. Another way to write a ratio, if you remember, is 1:5. And there's one more way of writing a ratio, which is as a fraction. Okay, this is a part-to-total ratio. Remember, there was part-to-part, but we're interested today in the part-to-total, and you'll soon see why. Okay. So copy this. Again, if you need more time, press pause at any moment, and then press play again. Okay. Next page. Okay, so another thing I want you to copy the top sentence here. Proportions. Two ratios are in proportion when they are equal to each other. Okay. So copy that. Press pause. Copy, and then we'll talk about the pictures at the bottom, which I do want you to copy. Okay. Alright, now pencils down for a second, and I want to talk about, and let's just pretend for a second we are talking about this particular scenario right here. So remember our initial ratio is that there is one heart for every 5 items, part to total. On the other side, thinking about this new set of items that we have, we can write that there are 2 stars for every 10 items. Now, the question is, are these two ratios in proportion? And I'm hoping you're going to say yes, because the increase here was times 2, and the increase here on the top was times 2. So if they increase by the same ratio, if the same ratio is happening over and over again, then they are in proportion. So we had initially 1 heart for every 5 atoms, and then we added another 5 items, and within those 5 atoms that we added, there was 1 heart. So that ratio was maintained. Okay. Now let's do it again, and then this one again, our initial ratio was 1:5, and thinking this as a new set of items, okay, we have that there are 3 hearts and 15 items. Okay, so did it grow from this? Okay, so let me rephrase the growth from this line, from these items to all these items. Did it grow in proportion? Was the same ratio maintained as it was growing? So obviously 5 to 15 is times 3, and 1 to 3 is times 3. So again, you can tell that these two ratios are in proportion. Okay, so you should remember this. This review was not that long ago. Okay, and then let's go to the next page. All right, so this whole page you need to copy. Okay, and press pause, copy, and then I'll talk about it. All right, just a couple of corrections I want to make as you're copying. Okay, so let's look at the statement that says 40% of the school are 6th graders. Okay, and we want to focus on the 40%. So 40%, percent, per means for every. Okay, and you know what that means by now. Cent means 100. You can think of other words that has the prefix cent, like century. That means 100 years. Something else that has something similar to that. Decade. Deca means 10. Kilo, kilometer. Okay, kilo means 1,000. So there's 1,000 meters, kilometer. So percent. So the word cent means or has a connotation of 100 or means 100. Okay. So in the second line here, we take the per, change it for every, and change a cent to 100. It literally means 40% means 40 for every 100. Okay. A percent is a part to total ratio where the second number is always 100. You're always going to be comparing it to 100. That's what percent is. That's why it's I guess a standard that we use. Okay, it makes life easier. You know, everybody knows what 90% is. If you got a 90% on a test, you know you did well. If you got a 20% on a test, you know you did poorly. So I guess we like using percent to use it as grades, as something to determine how well we did on something or how poorly we did on something. It's much easier. Okay, it's much easier than saying, hey, you got a 35 out of 42. That's very hard. We don't know exactly how well we did if we talked in that manner. But changing 35 out of 42 to percent, that would tell you how well you did. Okay? So copy the whole thing. On the next page, you don't have let's see here on the next page, which is this one, sorry. You don't have to copy the top, but everything starting from what does that mean down, I want you to copy. So again, press pause, copy, and when you come back, I'll talk about what's written in here. All right, so 40% of the school are 6th graders. So what does that mean? It means that if there were 100 students, 40 of them would be 6th graders. Or in our first sentence here, written in black, it says 40 for every 100 students are 6th graders. Okay, so we can also write a ratio for that. The ratio of 6th graders to total students is 40 to 100. Part to total. The total being 100 and part of that 100 being 40. So part of those 100 kids are 6th grade. It's a part to total ratio. Okay? That's what a percent is. So take a couple of seconds and I'd like you to do this exercise. 40% as a fraction can be written as 40 over 100, or there should be about 3 other fractions that also means 40 over 100. So you can simplify this. Okay, so take literally whatever 20 seconds to do this. Okay, simplify it, get the different fractions that mean 40 over 100. Alright, so 40 over 100. Another way of saying 40 over 100 is if I simplify that, and I can write that as 20 over 50. That's one way of saying it. Another way of saying that would be 10 over 25. Okay, I took 20 over 50 divided by 2. Another way of saying this would be from here, I can go this way and I can divide both top and bottom by 10 and say 2 over 5. Okay. Is there any other one? So 40 over 100 can simplify to 20 over 50, 10 over 25, 2 over 5. Oh, actually, there's one more. There's or. Let me write an or here. We can simplify to 4 over 10. Okay. So if they're all of these 4 new fractions, they all mean 40 over 100, which also means that they all mean 40%. So let's take a scenario here, right here, the one I'm circling. You had a quiz. You had 25 questions, you got 10 correct. That means that as a percent, you got 40%. Look at the one down here. You have 5 questions on the quiz, you got 2 correct. To change that to a percent, okay, you would divide 2 by 5 and you would get 40%. You actually would get 0.4, but that changed to a percent would be 40%. Or even the first one here. 20 out of 50. 50 questions on the test. You got 20 correct. What does that mean? It means that it is 40%. Okay? Let's do one more. So I want you to change all these percentages to a fraction in simplest form. So press pause. Take a couple of minutes because this will take a little bit longer. And when you come back, we'll go over it. So 35% as a fraction, it's something compared to 100. So it's 35 out of 100, or it's 35 for every 100. You should have gotten that initially. Simplified, you can divide top and bottom by 5. 35 divided by 5 is 7, and 100 divided by 5 is 20. Okay. 48% means 48 for every 100, 48 out of 100, and that's how we write it as a fraction. You can divide this by, let's see, 4. Divide this by 4, you can get 12 on top. Divide by 4 at the bottom, you get 25 at the bottom. 12 out of 25. So 48% can be written as a fraction as 48 over 100 or 12 over 25. If you didn't divide it by 4, you probably divided by 2. You got 24 out of 50, which can then be simplified to 12 or 25. 120. Ooh. Well, it's the same procedure. Still out of 100. 120 out of 100. That's how you write it as a fraction. You can change this. It's an improper fraction. Okay. So let's simplify it first. You can get a 60 out of 50. Divide top and bottom by 2, you get 60 out of 50. Divide top and bottom by 10, you get 6 over 5. It's an improper fraction, which I want to change to a mixed number. Okay, so 5 goes into 6 one time. You have 1 left over. 1 over 5. So 120 as a fraction can be written as 120 over 100, 60 over 50, 6 over 5, or finally, final answer, 1 1/5. That's what I would have liked to see on a test. Okay, that would be your final answer. Okay, so let's see what else we have. All right, using benchmarks and percents. Let's go over benchmarks a little bit. Benchmarks are numbers that we use frequently that are very easy to locate, very easy to recognize. Very simple to use. Okay, you'll get an idea once we do a couple of days. So copy this as it is. Okay, I'm just going to add a few things, and you're going to see what we're going to. So copy and students. Here it would be 0. At the end would be 30 students. Okay, we're going to use this bar to represent the number of students. So that's 0 and 30. And at the bottom line, we're going to use to represent the percent. And that would be 100%. Okay? So copy, pause. Okay, so let's see what we have. So 25% of the 30 students have blue eyes. How do we represent this on this bar here using benchmarks? Well, the first benchmark that we know of, very easy to recognize, would be right here. Everybody knows what 50% is. It's half. So that's a benchmark. Very easy to recognize, very easy to locate. No calculations needed. And just as well on the top line here, okay, 50% is half on the top line, whereas the number of students, half of 30 is 15. So those two locations were very easy to put on the two lines. Now let's figure out if we can get another benchmark. Well, if I know 50%, I also can find out what 25% is very easily. 25% is half, is the half distance between 0 and 50. That's the other benchmark that I can locate. But notice that I needed to find the 50% first, or the 15 on the top first, before I go to the 25%. I couldn't have done that right from the beginning. So I started with 50%, which was half, and then from there I took half of 50%, which is 25. So that's the location of 25%, which means that right on top of it is the location of 25%. 25% in terms of translates to what number? So 25% is the halfway mark between 0 and 50, and this mark is the halfway between 0 and 15. And the halfway mark between 0 and 15, half of 15 would be 7.5. So that's how I would illustrate 25% of 30 students. So right here I'll draw a circle. 25% and 25% is equivalent to 7.5 students. So 7.5 students out of 30 have blue eyes. And that's how I use benchmarks. I use the benchmark 50% and then 25%. Okay? Pretty easy? Okay, so, sorry, I'm eating chocolate. Let's try one more. 10% of the 60 students have blue eyes. Copy the whole thing, press pause. I'm just going to fill out a few things here. Top line is the number of students. In this one we have 0 to 60 students. Bottom line is your percent, so that's 0, and that will represent 100% of the students. Alright, so we'll do this together slowly. First benchmark. Well, I would always start with 50 because that's the easiest one to locate. There's my 50%. And 50% of 60 means that it's 30 kids. So, let's do 25%. That's another one we can do. Okay, and that's the half between 0 and 50, so the halfway between 0 and 30 would be 15. Does that help us with 10%? Remember when we did tape diagrams? Okay, tape diagrams, and there was a box here, and we cut it into pieces. In this case, 10%, and this works nice with percents that end in 0, 10, 20, not 30 because it can't go evenly to 100, but 10 goes in evenly to 100. How many times? 10 times. So we can actually do this. This is 10%, 20, a little bit would be 30, 40, 50, 60, 70, 80, 90. 10%, 20%, 30%, 40%, 50%, 60%, 70%, oops, 80%, let's just make one here, 90%. So remember when we did a type diagram? There were 1, 2, 3, 4, 5, 6, 7, 8, 9. Jeez, sorry. Okay, miscounting here. So let me just erase these last. 60, 50, 60, 70, 80, 90. Okay, so again, we have 10 boxes. Okay, 10%, 20%, 30%, 40, 50, 60, 70, 80, 90, 100. So think about it for a second. If I have 10 boxes and the total number is 60, how many would fit in here? If I had to break 60 into all those boxes, each box would have, well, 60 divided by 10 is 6. Let's put 6, 12, not that one because that's 25. This one will be 18, 24, 30, 36, 42, 48, 54, and 60. So that would be 10%, 20%, 30%, 40%, 60, 70, 80, 90. So 10%, which is right here, equals to how many kids? 6. So 10% of the students have blue eyes means 6 kids out of 60 have blue eyes. Okay? Now, doing this to figure out the number will not always work. Okay? Sometimes you'll get an approximate depending on the percent. Okay? Let's say that said 11%. Well, you can estimate 11 after having 6. After getting 10%, you can figure out that 11% would be maybe 6 point something or close to 7. Okay? You'll see what I mean. Next one. All right, copy. Try doing this on your own. Okay? And I'll just set this up for you guys over here. Students, that's 0 students. This is 120 students. And 0%. And that's 100%. So the statement says 100 kids out of, and you're forgetting, I forgot the of, out of 120 students have blue eyes. So I guess in this particular question, we want to know what the percent is. Think about it this way. There were 120 questions on the test and you got 100 correct. What was your grade? 80%, 90%, 82? Same thing, different scenario. Okay? So, press pause, try to do it on your own, come back. Alright, so I would start with the same thing here. That's 50%. 50% means half. Half of 120 is 60. Okay. I don't need to work with the smaller percentage, but I have to figure out the higher percentage. Well, 50 to 100, the halfway mark going up would be 75%. Okay, you know what? I'll just draw this even though I don't have to worry about it. These are the benchmarks that I can draw. 50, once I have 50, I can do 25%, and I can also do 75%. And 75% is the halfway between 50 and 100. So what's halfway between 60 and 90? Okay, halfway mark would be 90. Now, this is going to be that case where we're going to estimate. So if that's 90, Okay, let me change colors here. If that is 90, hopefully everybody can agree with me that about here is 100. 100 kids. 60 kids, 90 kids, I move a little bit more, 100. About here would be 110, and the final line would be 120. Well, if that's 100, let me extend that line to the bottom part right here. Now, what would you guess this location right here would be in the percent line? 75, let's see, 80, 90. You can call this, or I can call this, or you can call this. What's a guess here? 80? 80%. So, 100 students out of 120 students have blue eyes, more or less means that 80% of the kids have blue eyes if there were 120. So this is a case where we estimated, but we needed that benchmark 75% and the 90 above for us to approximate. See how much easier it is if I have 90 to locate 100? Okay? Yeah, that's that. Is there one more? Yes, there is. All right, try this. Again, press pause. Try it on your own. If it's not perfect, you can round. Okay, here's 0 to 400 students, and this is 0%, and this would be 100%. So in this case, we want to know, it says 150 students out of 400 have blue eyes. So if there were 400 students in the auditorium, 150 of them will have blue eyes. What percent would that be? Or there were 400 questions on your test and you got 150 of them correct. What percent did you get? Okay, press pause. Take a couple minutes or a minute. Come back and let's see how you did. Alright, so again, benchmark. I will start with the middle. That's 50%. And 50% of 400 means 200 kids. Well, so we don't have to worry about the top half here. So let's work on the left side. Well, 50%, if I have 50, I can also locate the halfway mark between 0 and 50, and half of 50 is 25%. And half of 25% means, let's see on the top, half of 200 means 100. So I have my benchmark 50%, which means 200 kids. Or if I said 25%, it means 100 kids. So, now 150, hopefully you can recognize that 150 is located where? Between, it's the halfway between 100 and 200. Okay? That's 150 kids. That's where 150 kids will be located. So if I drop that and extend it to the percent line, where would it drop? Well, it's the halfway mark between 100 and 200, which means it's the halfway mark between 25 and 50. Okay, so what's halfway between 25 and 50? What's the halfway mark? Well, to go to 25 to 50 is 25 steps, obviously. Okay, and 25 divided by 2 is 12 and a half. So this right here would be 12 and a half, and this right here would be 12 and a half. So 25 plus 12 and a half makes this 37.5%. That would be the halfway mark. Imagine if you were standing at 25 and somebody else was standing at 50, and you were both taking one step at a time towards each other. You would meet at 37.5%. It's likewise on top. If you were standing on top of 100 and somebody else was standing on top of 200, and again you were walking towards each other, you would meet at the 150 marker. Okay? Okay, this you copy. This is our percent proportion that you're going to be using. The benchmarks gives you an approximate idea, okay? But with this, you can get a more precise answer by using this particular setup. And you'll see how that works in a second. So copy this. It's called the percent proportion. It's this ratio of part to total equaling a percent over 100. So yeah, copy it. Press pause, copy, and we'll see how this works. Alright, so copy the question, copy the procedure on the right side, and leave this space right here. Okay, and we're going to figure out how to use this particular setup for this particular question. Okay, so press pause and copy. Alright, so how do we use the percent proportion for this? Now, the one thing, that proportion you just copied, it always starts like this. So you got 3 blank spots and the 100 over here. On top of the 100 always goes the percent. In this question, it says Justine got 18 out of 20 on her science test. What percent did she get? So obviously this particular spot, the percent, in this case, we don't fill it in, but we leave it empty. Or in this case, I'm just going to leave it with a question mark because that's what we want. That's the part that's missing. The other piece of information that we have is 18 out of 20. 18 is the part and 20 is the total. So there were a total of 20. That's what we do at the bottom, write 20 because that's the total. And 18 is a part of that test that she got correct. And this becomes something that you should know how to do by now very, very easily. Okay, just like when we did it in the beginning, the review section. Now, you can try to figure out this number by finding that relationship. Okay, so 20 to go to 100 is times 5. And 18 to go that way would also be times 5. Okay, if you multiply the bottom by 5, you must multiply by the top by 5. So 18 times 5 gives you, 5 times 8 is 40, goes 4, gives you 90. So the percent, which is what you were missing, is 90. So you can write at the bottom, Justine got a 90% on her science test. Okay, simple. The key here is filling this part right here. That's what you need to fill in correctly. Okay, and then find the relationship between the two ratios. Very easy. Copy, press pause, and then we can work on this together. Okay, so, but again, I'm going to write your setup. All right, so press pause, copy the question, and then we can do it together, or you can try it on your own if you're comfortable already. All right, so Katrina does the family laundry 80% of the time. If the laundry was done 25 times last month, how many did Katrina do? Okay, so she does 80% of the time she does the laundry. So there are times she does not do her laundry. So last month, that house did a total of 25 times, laundry 25 times. She obviously did quite a lot of those. So we're trying to figure out of the 25 how many she did. So 80%, you were given a percent here. Remember, percent. So it's percent over 100. So we know that that number here is given to us. In this case, we write 80. On the other side, remember the top one is part. Not right on the side here, part. And the bottom is total. And you have this number over here. 25 times. Was 25 times the total amount of laundry that the family did, or part of the laundry? Okay, so 25 times was the total amount of times they did the laundry last time, 25. And we need the part. The part is going to be the part that Katrina did the laundry. Okay, so out of 25 times, she did a part of it. So again, look for the relationship. This time we're going this way. 100 to become 25 is divided by 4. And that same relationship is going to be applied on top. So you got 80 divided by 4, which is 20. So out of the 25 times that the family did laundry last month, 20 were done by Katrina. So Katrina did the laundry 20 times. Okay? All right, you're on your own on the next one. Copy the question, press pause, and then we'll do it together. Okay, so Taylor won 17 out of 25 games. What percentage of her games did she win? Another way of thinking about this is she got 17 out of 25 on the test. Well, what's her percent? So let's fill this in. 100 will always go in here. Percent is what we're missing, so you want to put a question mark, you can. Leave it blank if you want. And then 17 out of 25. 17 is the part that she won, and 25 was total number of games. Remember, it's always part over total. And again, look for the relationship. 25 to go to 100 is times 4. And obviously, that same is going to be applied on top. 17 times 4 is 17 times 4, 78. So, she won 78% of her games. Okay? Try again. I think there's another one. Yes. Okay, 60% of the class will not attend summer school this year. Ooh. If there are 50 students in the class, how many will not go to summer school? Why did I make this question so easy? I don't know. But nevertheless, copy, try. Press pause, of course, and then come back. So, this should have been your setup. And let's see, the information that we have 60%. They give you the percent here. So 60% goes here. Okay, 60 over 100, 60%. That's what 60% means, something out of 100. And let's see, the other piece of information we have, there are 50 students in the class. 50 students in the class means that there are a total of 50 students, so total goes at the bottom. The part is that little piece of information we don't know. So part of that class, so part of the 50 kids are not going to summer school. So what's the relationship here? Well, from 100 to 50 is divide by 2. And we're going to do the same thing on top, 60 divided by 2, giving us a nice number, 30. So this means that 30 kids will not go to summer school, will not go to summer school. Okay. Okay, and that's that for that one. Okay. This one's a little different. So, copy the question. There's an extra step in this one. Okay. I'll write it here. But I'd like you to try it anyway. So press pause, try it, and then let's see how you did, and then we'll do it together. Okay, so this is what we have. So let me write 100. What percent? 24 people out of 80 love pizza. Out of, I forgot the of again. Out of 80 people love pizza. What percent is that? So again, you can think of pizza. You can think of games. You can think of grade. Her test. There was 80 questions. She got 24 correct. What percent did she get? Okay. So percent. This is the one that we want. Leave it as a question mark. We don't know what the percent is, but we know that 24 is the part. So part of this group of 80 likes pizza. 24 people out of 80, part to total, like pizza. What's the problem here? I'm hoping that you notice that there is no relationship that goes from 80. There's no number that you multiply by 80 becomes 100. Okay, no nice number. Okay. So there was something here that you had to do before. Okay. Well, that's why I wrote simplify here. So let me take 24 over 80 and simplify. If you simplify, you can, let's do this the long way. Let's divide by 2, top and bottom. Divide by 2, you get 12. And divide by 2, you get 40. So let me take a second over here. And let me come back, erase this. Okay, and I'm going to write 12 over 40 of us. Now, is there a relationship here? There is, but I want a nice relationship, a whole number relationship. 40 times no whole number will give you 100. So that's still not what we want. So let's simplify 12 over 40 again, and let's divide that by 2 and divide the bottom by 2. That gives us 6 over 20. And let's substitute. Let's erase that again. And instead of 12 over 40, let's write 6 over 20. Ooh, now there is. 20 goes into 100 5 times nicely. 20 times 5 goes into 100. So 6 times 5 will work, giving us an answer of 30. So that means that 30% love pizza. Now, some of you might have done this. Divide by 2 again, and gotten 3 over 10. And guess what? I'll do it on the side here. So instead of using 6 over 20, you could have used 3 over 10. Why? Because 10 goes nicely into 100. 10 times 10 goes to 100, and 3 times 10 gives you 30. You get the same answer, 30%. Okay, so whether you use 6 over 20 or 3 over 10, it didn't matter because you got the same answer. As long as you find a relationship that works. Okay, so we had 24 over 80, that didn't work. 12 over 40, that also didn't work, but 6 over 20 did, and 3 over 10 did as well. Okay, so 30% loves pizza. Okay, so in this case, you had to simplify. Okay? Next one. 18 out of 60 people love pizza. What percent loves pizza? All right, so try that. And instead of, well, try it first. So, here's 100. Percent is going to be the empty spot, so put a question mark. And let's put 18 over 60. So, I'm hoping you realize that there's no relationship between 60 and 100. Nothing times 60 will give you 100, whole number. Okay, so you have to simplify. So let's take a second here and simplify. 18 over 60. You can divide that by 2, and you get 9 over 30. So let me erase this. And I'm going to write 9 over 30. And that's also not going to work. 30, nothing times 30 equals 100. So that's not a good choice. Well, let's simplify that again. 9 over 30 can be simplified, divided by top and bottom by 3. 3 over 10. Now it works. So 10 times 10 is 100. And 3 times 10 is 100. So again, coincidentally, same answer, 30% loves pizza. Okay? Alright. Same question, but I changed the first number. 7 out of 60 people love pizza, or percent loves pizza. So in this one, it's a little tricky. So see if you can do it first. Okay. Press pause, see if you can do it, and then if you can't, it's okay. Because this one's a little bit different. Alright, so in this particular problem, you will notice that 7 over 60 cannot be simplified anymore. Okay? Percent's what we want. So what is our other option? So here on the side, I don't know what to call it. Let's call this amplify. Ugh, I don't know if I like that word. But because I can't think of anything else, let's call it amplify. Previously, we simplified, which made it simple. We decreased it. So with 7 over 60, we're going to go the other way. We're going to increase it or amplify it. So we know that 7 over 60, it's not going to work. So let me erase that and create a new one and leave that blank for now. Let's increase it. So 7 over 60, if I want to increase it, let's increase it, I don't know, let's take it times 2. Times 2 bottom times 2 top gives us 14 over 120. Let me take that new fraction and write it over here, 14 over 120. Is that going to work? Is there something, in this case, division, 120 divided by something that it gives you 100? No, that's not going to work, so let's go back. Okay. What if we did times 3? 7 times 3 is 21, and 60 times 3 is 180. You think 21 over 180 will work? Is there a relationship between 180 and 100? So you get the idea that in this case we're not simplifying, but we're amplifying. We're increasing it by the same factor. So times 4. Okay, let's see what happened when it's times 4. 7 times 4 is 28. 60 times 4 is 240. And that also wouldn't work. There's no relationship between 240 and 100. Let's take it times 5. Times 5. 7 times 5 would be 35. And 60 times 5 would be 300. Here's a nice number. So let me write that. 300 at the bottom and 35 on top. Now can you see a relationship between these two? Hopefully you can. 300 to become 100 is divide by 3. So you can do the same thing on top. Divide by 3. Okay, it's going to give you a decimal because it's not going to be exact, but that's okay. So 35 divided by 3, it's going to be, if you calculate it, 11.6, and it's going to be 11.66666 forever, or you can just put a bar notation like that. Say, so it's 11.6% love pizza. Okay. little bar. Okay, so we had one where we simplify, and now we have other ones where we can amplify. Okay, so that's that. So right now I want you to take 5 minutes, and I want you to go to your left side, and I want you to fill it out. So this is the proof. Wait a second. Hang on a second. Yeah, we can use this one as a proof. Okay, so in your proof, I want you to copy that question and create a little line at the bottom, and you're going to do this on one side, and you're going to create this on one side. All right, so you're going to use both ways. So let's write beagles here, percent at the bottom. So that's 0%, this is 100%. That's 0 dogs, and this is 600 dogs. Okay. So remember one thing, when you're doing it with benchmarks or the bar on the left side or the double line, not all the time you will get the answer that you're looking for. Sometimes you might just have to estimate. Okay, and that will help you with your proportion because they should be very close to each other. Sometimes using the double line will give you the right answer, or the exact answer I should say, but sometimes it won't. So start with your learning goal. Learning goal. If you guys forgot, what did you learn? Okay. So what was the learning goal? What did you learn after all these problems? Fill that out. What do you know? What did you know, I should say, before you started this? Fill that out. What did you learn is the third one. Okay, so the learning goal is the aim. Okay, so what was the aim of this? So what do you know is what you knew. What did you learn, obviously, is what you learned throughout these exercises. The proof is on screen right now. I want you to copy the question. 7% of 600 dogs are beagles. How many are beagles? And I want you to solve it. Okay. And then your reflection. Okay, reflection is your own feelings, your own thoughts about this. Is it too easy, too hard, too complicated? Things that you may need to remind yourself so that this becomes easier. A little note to yourself. So that's your reflection. So, okay, so press pause, take a few minutes to do that, come back, and we'll finish this. All right, so let's do the one with the double line. So I know this is 50%. If that's 50% means 50% of 600, or half of the 600, means 300 dogs. Okay, now 600 is a nice number. Okay, I can't get to 7%, but I know that I can get to 10%. So let me write this down. 10, 20, 30, 40%, 50%, 60%, 70%, 80%, 90%. Here's my 10% right here. That's the benchmark I want to use. 10%, that would be 1, 2, 3, 4, 5, 6, 7, 8, 9. So remember, type diagram. Okay, I'll even do this. Okay, I'll join top and bottom line. So there are 10 boxes over here. There's 600 dogs. How many would go in each? 600 divided by 10 would be that each box means 60. 60. The next one will be 120, 180, 240, 300, so forth, so forth. So 10% is 60 dogs. We're not interested in 10%. We're interested in a little bit less than 10%. Let me change colors. And it will be somewhere around here. Okay? So I know it has to be a number less than 60. And here is a case where you can approximate, I don't know. So a little less than 60, because 10% is 60 dogs. 7% would be about, I don't know, 45. Okay, so let's just choose 45. So 7%. Okay, 7%, it's about 45 dogs. So if you said 7% of 600 means about 45 dogs. Well, let's see if we're right. On the other side, this is where we start off. The information is given us as 7%. They give me the percent, so the percent 7 goes on top here. And we have a, again, part total. Next piece of information I have that there are 600 dogs. Is that the total or the part? That's the total number of dogs. Okay, so the part is the part that we're missing. 100 to 600 is times 6. And 7 to that is also times 6. And 7 times 6 is 42. So if there are 600 dogs out there, 42 are beagles. Look how close we were. Here we estimated that about 45 were beagles, but in fact it's 42. So this side here helped us almost, double check our answer. Okay, I knew it had to be somewhere around the 40s, and we ended up getting 42. Very, very, very close. Okay, you're going to get a sheet from your teacher, and there's going to be two sides. One side is going to be about benchmarks, about 5 to 6 problems on benchmarks, and the other side is going to be with proportions. That's for homework. There are 2 Learn Zillion videos I'd like you to do today. Okay, and that's that. Okay, I will post this video on the class website, so if you want to watch it again at home, you can. And that's about it. Okay, and hopefully I'll see you guys soon. Okay, any questions, please email me. And that's it for now.